Welcome everyone to this video. We are going to discuss question number 3 in this paper which happened in 2023 JEE Advance. So the question is that you have resistors 15 volt, 5 volt and the current flowing in 1 ohm resistor is 1 ampere. So how that current flows that defines a lot of things. So we'll say that the potential difference supplied by the 15 volt battery is much higher than the potential difference which is existing in the other branch of the circuit. So that means that the current must flow in this direction. That is, it's going to flow in the direction opposite to the uh, battery terminals signs. That is, the battery wanted the current to flow towards rightward direction, but the current will flow opposite to that because the potential difference provided by 15 volt is much higher. So let's see what happens. So now we have evaluated that the current which is flowing uh, through the circuit, uh, this here value, the current which is flowing is 1 ampere. This current is I1. So the current which will flow here would be some I1 plus 1. So let's see. We have 15 minus I1 plus 1. This is equal to the potential difference across this whole circuit when we go from this point to this point, from point P to point Q. So that potential difference is plus 5 and plus 1. So that is 6 volts. This is also equal to potential difference across points P dash and Q dash. So this would be again, as we are going from point P to Q, potential is rising. So its value is going to be 3 times I1. So I1 is going to be simply 2 amperes, and putting the value of I1 here we'll get 15 minus 3R is equal to 6. So R will become equal to 3. So option A is correct. Now when key is closed, uh, what is I1? Our key is not closed because key is closed at t is equal to t naught. So below that time, what is the value of current I1? The value of current I1 is 2 ampere, which we calculated. So that is also correct option. Then the current in the capacitor is zero point 0.6 amperes at this t naught plus some 7.2 microsecond time, and charge in the capacitor is 12 microcoulombs at infinite time. So this is the critical point, basically how to do this. So mainly in these kinds of questions, what we do is that we basically short the batteries in the circuit, because to calculate the equivalent resistance in such a circuit, we are left with a lot of calculations. Rather, what we do is that how the capacitor sees the whole circuit. We want to see that because we are concerned with the current of the capacitor. So to find the resistance of the whole circuit, we can simply short the batteries. That is, there is no battery there and simply resistance are existing. So this resistance we have calculated as 3. So if we calculate the equivalent resistance of 3, 1 and 3, it would come out to be some 3 by 5 ohms. That would become in series with this 3 ohm, that would become some 18 by 5 ohms. So we know that the time constant of our RC circuit is R into C, capacitance being 2 microfarad. So this would become some 3, uh, exactly some 7.2 microseconds. which is the time given in the question. So this is the time constant. Basically, at that time, the current in the circuit I becomes 1 upon E times its maximum value. What is the maximum value of current in the circuit? So maximum value of the current in the circuit is simply when the capacitor is completely charged. So when the capacitor is or when the capacitor is actually uncharged. So in the uncharged state, what we will see is that the current in the circuit uh, would be this 3 ohm and 3 ohm. This will become parallel, right? And we have already established what is the uh, potential difference across points P and Q. The potential difference across points P and Q is 6, and the equivalent resistance of these two resistors is 1.5. So 6 upon 1.5, that is 4 amperes. So 2 amperes of current would be flowing here. So that means the maximum current would be 2 amperes. Uh, Dividing that by E, that is 0.36, right? So it would be something like this. That would be some calculation, or not dividing, basically multiplying. That is what is given, that 1 by E is 0.36 to into 0.36, and this has to be divided by something else as well. Maybe it is divided by um, some 7.2, something like that. Let me see what is the calculation. I is equal to I naught uh, e की power minus t upon rc. Right, this much we know. So we know the maximum charge in the capacitor is 12 microcoulomb, right? So the maximum charge is q. So when we differentiate that equation, r comes in the denominator. So we'll have 7.2 in the denominator as well. This whole thing RC8 will come in denominator. So 2 upon 7.2 into 0.36. So that will give you 0.6 amperes. Thank you for joining.